All right, let's talk about the Leaning Tower of Pisa. It's one of the most famous buildings in the entire world, right? A true marvel, but it's famous because of one huge, glaring problem. This is the story of how a team of modern engineers pulled off an incredible, high-stakes rescue mission to save this icon from itself.
I mean, for centuries, millions of us have gone to Pisa, Italy, just to see this amazing bell tower. And, we all take that classic photo, pretending to hold it up. It's just a totally beloved icon.
Well, here's the scary part. That question isn't a what if. By the end of the 20th century, that famous lean wasn't just some quirky photo op anymore. Nope, it was a critical failure that was pushing the whole 14,500-ton structure right to the absolute edge of collapse. So, to understand how they managed to save the tower, we've got to go back to the beginning. We need to figure out why it started leaning in the first place. And that story starts way before a single stone was laid. It starts deep in the ground itself.
Okay, so this right here is the heart of the problem, the geology. Millions of years ago, a river left behind all this silt and soil, and it created this dangerously unstable mix. You've got sand on the north side, but on the south side, it's this soft, mushy, compressible clay. It was, quite literally, a recipe for disaster.
And here we have the first huge engineering mistake. The original builders, well, they only laid a foundation that was 3 meters deep. For a building this heavy, on soil this shaky, that was just nowhere near deep enough. The tower was pretty much doomed to sink from the moment they started.
So, that initial mistake kicked off a kind of chain reaction, one that played out over the next 200 years as they built this thing on and off. It turned into this multi-generational battle against gravity itself. Just look at how this all unfolded. They start building in 1173, but just 5 years later, they have to stop. Why? Because the tower is already sinking into that soft clay on the south side. A whole century passes, and when they start up again, the masons get this clever idea. They just build the new floors taller on the sinking side to try and even things out. And then they did the exact same thing with the belfry 100 years after that.
So here's the wild part. All those attempts over the centuries to fix the lean, they actually gave the tower its unique shape. It doesn't just tilt in a straight line. It actually has a slight curve to it. It's this 800-year-old story of near disaster and quick thinking, and it's all written, literally, in stone.
For hundreds of years, the tower just kept leaning, a tiny fraction of a millimeter at a time. But by the 20th century, that slow, steady creep had turned into a full-blown crisis. By 1990, the tilt had reached a terrifying 5.5 degrees. Now, what does that even mean? It means the very top of the tower was hanging out more than 15 feet from its base. It was so bad the Italian government finally had to close it to the public. They were afraid it would just fall over.
Now, to really get just how bad things were, you need to know this quick engineering term, factor of safety. It's basically a buffer. So a factor of 2 means a structure is twice as strong as it needs to be. A factor of 1, well, that means it's holding on with absolutely zero margin for error.
And get this, by 1993, new analysis showed the tower's factor of safety was just 1.07. 1.07. That's a tiny 7% safety margin. One bad storm, a small earthquake, and the whole thing could have come crashing down. It was holding on by a thread.
So they called in the cavalry, an international committee of engineers to figure out a solution, and they knew they had to work fast. Their first few tries, though, they were a mix of just brute force and near catastrophe. The first thing they did was an emergency measure. They just stacked 600 tons of lead ingots on the tower's north side, the high side, to act as a giant counterweight. And you know what? The crazy thing is, this ugly, brute force fix actually worked. For the first time in its entire history, the tower started to move back towards being straight, even just the tiny bit. But, I mean, look at it. It was a total eyesore and definitely not a permanent solution.
So the success of the counterweights bought them some time. The committee then came up with what they thought was a much more elegant, more permanent plan, using 10 deep ground anchors to pull the foundation down on the high side.
Yeah, about that. It went horribly wrong. As they were getting the ground ready for the anchors, they accidentally disturbed the tower's delicate balance. The tower lurched south, leaning faster than it ever had before. It was a terrifying moment. They had to scrap the plan immediately and pile on even more lead weights just to keep it from falling over right then and there.
So, after that near disaster, the committee went back to a totally radical, counterintuitive idea. It was incredibly delicate. Instead of propping the tower up, what if they let it settle down, but in a super-controlled way?
The process was called under-excavation, and it was basically engineering as surgery. They would drill these carefully angled holes under the north side, the high side. Then a special corkscrew-like auger would go in and remove a tiny bit of soil, leaving a small empty space. When they pulled the auger out, the ground would gently compress, and the whole tower would settle just a fraction of a millimeter into that new space, nudging it back toward vertical. You have to imagine how slow and precise this was. Over the course of a full year, they performed 41 of these drills, removing about 70 tons of soil in total. We're talking one handful at a time. It was painstaking work.
So what was the final result? The project reduced the tilt by half a degree. Now that might not sound like much, but it was huge. It effectively turned back the clock 200 years, taking the tower from the absolute brink of collapse all the way back to the more stable lean it had in the early 1800s.
And this quote, it just gets to the very heart of the whole project. The engineers weren't trying to fix the mistake. I mean, a perfectly straight Tower of Pisa would lose its soul, right? The real goal was to stabilize it, to make sure its story, its glorious, wonderful imperfection could continue.
So you see, this whole stabilization project wasn't a correction, it was a continuation. It was just the latest chapter in this long, long history of people stepping in to keep this beautiful, flawed tower standing. The lean is just part of its identity. It's in its DNA.
And that really leaves you with a fascinating thought, doesn't it? The project didn't erase the tower's flaw. It celebrated it by making it safe. It makes you wonder, what other so-called imperfections in our history and our culture aren't mistakes we need to fix, but are actually the most priceless, defining parts of our story?